Hello everyone, and welcome to this new workshop about the massive Worlds Toolkit. Today I'm going to be talking about how we can use the toolkit to craft a world building pipeline using the massive Worlds Toolkit and Houdini as a foundation. Basically, we are going to be building a tool of our own built on top of the toolkit, and I will show you how to integrate it with its existing pipeline so you can expand upon it yourself. My name is Erwin Heims, and I've been a technical artist at Ubisoft for the past 9 years. I've used to work on Ghost Recon Wildlands, Ghost Recon Breakpoint, and Riders Republic. Now, since last year, I've been a procedural pipeline consultant and Houdini teacher at my own company, E-Houdini Academy, where I provide procedural R&D consulting services. I also have created a lecture called the Procedural Asset Production Masterclass, which has 50 hours of content currently available on my YouTube, and it teaches beginners how to use Houdini, get them up to a foundation level. And then next to that, I've been a senior technical artist at Fracture Labs for the past year, where we're working on the game Decimated. But of course, in this video we are going to be talking about the Massive Worlds Toolkit, which I've been developing for the past 1.5 years now, and I plan to continue working on for quite a bit longer still. So let's talk about what we're going to do in this workshop. Now, since this video is going to be quite long, depending on where you're seeing this workshop, it's either going to be provided as a single video or it's going to be split into chapters. So let's discuss first chapter 1, where I'll be introducing to you the Massive Worlds Toolkit version 1.1. I will show you how you can get set up with the toolkit. We'll give a quick overview of the key Massive Worlds Toolkit nodes that you can use for your own tools, and I will highlight some useful techniques that you can set up with these nodes to create your own assets. And then in the next chapter, chapter 2, we'll be having a look at the example assets that are present in version 1.1 of the toolkit. We'll be looking at the road barrier spawner, you can see it down here, and then we'll also have a look at the simple biome spawner or the simple spawner asset, which is the tool that's creating all these trees that you're seeing in the background. And then in this next chapter, we'll be having a closer look at the mesh stamps tool. This is the main project for this workshop, and we'll be having a closer look at that in just a second. And we'll be looking closely in chapter 4 at how this tool is created. I'll be doing a step-by-step breakdown of the mesh stamps tool in Houdini, where you'll also learn how to use several of the key Massive Worlds Toolkit utility assets. And this should allow you to use them yourself in your own assets so you can build on top of the toolkit's framework. And then finally, in this last chapter, we are going to take the output of the mesh stamps tool and we are going to integrate this within the existing Massive Worlds terraforming pipeline. So basically what we'll do is we're going to break down how the current road terraforming pipeline and PDG task manager work within the toolkit. And then we'll look at how the mesh stamps tool is integrated into this pipeline, creating a second stage of terraforming before its output to Unreal. So in this workshop, we are going to create a new landscape mesh stamping tool, which is built on top of the Massive Worlds Toolkit using various of its component nodes. We're going to feed it these houses, place them in the world, and also draw a couple of roads out using blueprint splines. And then we are going to feed this to the tool, which will output a new mesh stamp that will transition the building footprints to the terrain and make sure that they don't overlap the roads, there's good transition, and eventually we'll be able to walk in this environment without any gaps or basically floating buildings going on. Let me first introduce you what the Massive Worlds Toolkit is, so you have a better understanding about what it's capable of, and then we'll move into creating our own tools for it. Here I have a small video I'd like to show you. This is the trailer of the latest version of the Massive Worlds Toolkit, version 1.1, with its new road building pipeline additions. Alright, pretty cool. So let me quickly explain to you what the Master Worlds Toolkit is. As you might have gathered from this video, the Master Worlds Toolkit is a Houdini-powered open world framework for the Unreal Engine 5. It allows for lossless transfer of the Unreal landscape data between both Houdini and Unreal, and it handles the landscape data in a memory-efficient way. Next, the toolkit externalizes both Houdini and Unreal data, such as the landscape and road splines, as well as the data between tools, and it allows the tools to synchronize in both applications. And for version 1.1, I've included an advanced road terraforming and infrastructure toolset, plus various example assets for biome and road propsing. So here are a couple of images. Like I showed you in the trailer, we can generate bridges, various roads, tunnels, road propsing, as well as vegetation across a large swath of landscape driven by a simple spawner example. We can also use blueprint splines to draw out roads, and we can manage and create even larger landscapes than we could in the previous version of the toolkit. So let's quickly talk about how you can get hold of the toolkit so you can get started with it in this lecture. First, you can access it when you subscribe to my Patreon. Basically, you just go to my Patreon, subscribe to the second tier, the invested tier or higher, and then you can find this post, which will provide you all the links and files necessary to get started with the toolkit. Right now, the toolkit is released using black box assets for Patreon backers. So like I said, if you do subscribe to this tier of my Patreon, you will get access to a limited commercial license to the Master Worlds Toolkit. You will also gain access to the project and HDA download links. I periodically release live streams or videos exclusive to my patrons. You will get access to future releases of the toolkit. And of course, you will get Discord access for feedback, questions, and live updates on its development. Now, for those of you who want to use the toolkit for commercial projects, if you don't meet the conditions for the Tier 0 license, then you should buy a commercial license from me. In order to know more about these licenses, please visit my website at ehoudiniacademy.com/licensing. And here you will find options for single and unlimited project licenses, as well as different licenses for either black box assets or the source code for the toolkit. You'll also find information about pricing and breakdowns of the licensing conditions in general. But anyway, let's move on. Alright, so once you've downloaded these files, you should have these 4 RAR files. I've split them into several pieces because they're a bit smaller and easier to download instead of one big package. But you should just grab them and unzip them. And once you've done that, you should have these set of files here, which will include the Houdini workshop scene, the Unreal project itself, and the example cache files, which create the backbone of the landscape project that we have in the Unreal scene. Okay, so first we need to actually install the tools from the toolkit into the example file, because they're not included by default. What you want to do is go to the Blackbox HDA folder, find the OTLs folder inside that, and grab all of the assets. Then go to the Houdini example project, go to the Massive Worlds OTLs folder, and paste them in there. Now that basically means that now the example project has these OTLs inside of it, but we still need to actually tell Houdini where to find the Houdini assets. So in order to do that, we are going to place a JSON file, which is included with the toolkit, into the My Documents Houdini 19.5 packages folder. If you're using Houdini 20, you should drop it into the Houdini 20 packages folder. And if this folder does not exist, you'll want to create it. Just basically add a folder into the Houdini, respective Houdini folder called packages. Next, you should open up this JSON file with a text editor, Notepad will do, and then change the first line to match the folder in the Houdini example project. Find the Massive Worlds folder, and put it in there. Then just go ahead and save this file. So in order to run the toolkit, of course, you will need to make sure you have the Houdini engine. If you have Houdini 19.5.805 already installed on your system, you're probably fine, because I've pre-installed this Houdini engine with the Unreal project. If you go to the Unreal project folder, go to plugins, you will find the Houdini engine installed there. Now, if you are running a newer version of Houdini, or Houdini 20, you'll want to remove that folder and then replace it with your own version of the Houdini engine. You can get that from the engine plugins from the Houdini launcher. Just click on the gear icon next to the version that you want to grab. Find the path to the folder, grab the 5.3 folder, and then drop it in here, just like that. You want to make sure that both the Houdini engine has a matching Houdini install on your system, and at minimum you will of course need a Houdini Indie license to run the Houdini engine. If you've got this sorted out, then you're ready to go. Now, if you've done all of this correctly, then the toolkit should now be properly installed, and both Houdini, Unreal, and the Houdini PTG should be able to see all the cache folders of the toolkit, as well as the HDAs. Now, when it comes to these cache folders, they are generally organized in this structure here. We have a root folder, which is the Massive Worlds folder. Then we have the cache type. Inside of those you'll find the project name, which is synonymous to the landscape name in Unreal. Each landscape will have its own project name. This is how the system is organized. And then the files or file sets for that project, for that cache type, are located in there. So this will translate to, for example, the cache folder, having the cache, then the project name, and then the cache files. The presets are also stored like this as well as the data tables, which we can export from Unreal to a CSV file for Houdini to read externally. When it comes to tiles, they are organized inside tile layer names. So each layer in the landscape has its own subfolder, and inside there you'll find the tiles. And if you have copies of the folders for your layers, such as a source folder or the snapshot folder, we'll cover that later, they also exist in their own subfolder like so. So have a quick look at that. For example, here again we have the Massive Worlds folder. If we go one level deeper, we come to the content of the Massive Worlds folder with all the cache types. And you can see here that it contains all the data that the Massive Worlds Toolkit will use to communicate between its tools and to send data back to Unreal. Now, if we go inside of the cache folder here, you'll end up here at this level where we have the project name folders, one for each landscape. We have Workshop L1 or Landscape 1 and Workshop Landscape 2. So each landscape has its own subfolder here. If we go inside of one of those, we end up in the cache folder for that landscape, containing all the information that is normally sent from one tool to another within the toolkit. Among other things, in here you will find the road data, you will find the world data, which describes where in the world the landscape is located and how it is constructed. You will find the multi-project data, which identifies that this landscape is actually paired with another landscape. It allows tools to load both landscapes at the same time. There's the props folder internally, which contains the props for the vegetation, for the simple spawner. And the mesh stamps, which is the folder that we're going to be using for this workshop. This is where our stamps are going to be located for each village. Now, in order to run the toolkit, I have a couple of recommended settings. If you're going to use the toolkit with a low-end system, like 32 gigabytes of memory, 12 gigabytes of VRAM, I recommend these particular landscape sizes. If you have more memory available, you can load a larger portion of the map. However, optimally, if you want to create a large world at high precision levels, such as 1 meter per pixel, I do recommend that you have 128 gigabytes of memory in your system and 24 gigabytes of VRAM. This makes everything a bit easier and allows you to run both Unreal and Houdini simultaneously without worrying about running out of memory at any point. At least if you're, being reasonable. So when you're using the toolkit and you only have a limited amount of memory available, I recommend that you only load landscape 2. That's basically the left landscape and it's the smaller one. On the other hand, if you have enough memory available and sufficient VRAM, then go ahead and just load the whole landscape as a whole. It means that you can see the whole world at once. That basically means the left area here, or otherwise, the entire map. Now the reason that this works is because we actually have multiple landscapes in the map, and the toolkit, as well as Unreal 5.3, supports multiple landscapes with seamless transitions. So we can basically create roads and paths and terraforming across multiple landscapes in Unreal without having to worry about seeing any kind of seams. There are a couple of pros to this, but also a couple of cons. The pros are that it allows for smaller data sets that can be processed individually with lower memory usage for each, as well as that large landscapes can be exported into parts, right? So basically we can export each landscape as a separate piece, and that's basically its own data set. On the other hand, of course, if you have a lot of these landscapes, you'll have more data sets to manage, and manual landscape sculpting in Unreal doesn't natively transition between landscapes, so you'll have to find a solution to that. Shouldn't be too hard. You can probably create a post-processor with the toolkit and handle that way. Now, when it comes to actually combining and working with multiple landscapes, version 1.1 of the toolkit now also has a split and splice node that is lossless. It basically allows you to optimize the landscape data in Houdini by only loading sections of the map that you actually need to edit. It can combine multiple landscapes together, and it can filter landscape layers as well, which will reduce your memory overhead. Now there's one caveat. If you go and create a landscape with 7, 13 or 15 tiles, it can create microscopic noise in the height field, basically tiny offsets, that on their own don't really do much to the final result. But if you do this cutting and combining operation multiple times in a row, before you export it back to Unreal, it can accumulate the tiny amounts of noise, and overall I would recommend you avoid that. The toolkit does try to avoid cutting to these numbers. It will try to upscale to the next valid number it can find, so it avoids this problem. But if you create a landscape that's actually 7, 13 or 15 tiles in width, it's not something it can avoid. So I would recommend avoiding these particular landscape sizes. Okay, now before we continue, I quickly want to show you an option that will allow you to use far less video memory when working with the landscape in Unreal. And if you're going to use the toolkit, you might want to enable this when you first open up the project, so you can actually run the project more easily. Now let me explain what this is and how we can use it, and also a couple of caveats when it comes to other functions in Unreal, because this isn't enabled by default. What we are going to enable is a console variable called edit layers local merge. In fact, if we go and look for that, we can find it under landscape, edit layers local merge enable. You can set this by manually clicking this, but what we are going to do is we're going to enable it by default using a settings option from the tools menu up here. Now, what does this option do? Edit layers local merge basically changes the way how Unreal landscapes are computed in the background. The different edit layers, as well as the paint layers, are usually composited on a landscape-wide basis using a render target, or basically virtual texture render plane, and whatever components of the landscape are currently loaded, that will scale up the render target size. Now this was fine for old landscapes in Unreal that were maybe 4x4 kilometers or 4x4K textures. But with the advent of streaming proxy landscapes and even larger worlds, this has become a bit of a sticking point. Because the landscape here on the left is a 4x8K landscape. and the one on the right is a 6x8, meaning that they take up a lot more memory to be loaded into your video RAM. And if this runs out, and your regular memory runs out, and if both run out, Unreal simply outright crashes. Now, if we actually enable Edit Layers Local Merge, what it will do is, instead of creating a virtual texture for the height map and the materials for the entire landscape, it will create it per component in the landscape. So every landscape component is going to get its own little virtual texture composite map. And this will allow it to compute the landscape in an asynchronous way, and it uses far less video memory. Now, this is disabled by default because this is actually still bound to a couple of legacy functions within Unreal, and until Epic has cleared those up, this function probably will stay disabled by default. Now, that said, in Unreal 5.3, most of these functions do work, but I have noticed that landmass doesn't receive benefits from this option. Now, when you're using the Master Worlds Toolkit, I don't think you have to use landmass. I have not excessively tested landmass with the Master Worlds Toolkit, so keep that in mind. But basically, if you're going to be using my road system, you also don't need splines either, but you could, right? Now, in our case, if I were to use, say, the spline editor here, I can still create landscape splines. So I could go and drag this out and procedurally deform the terrain, right? And if we were to look at our video memory usage, that doesn't increase a whole lot. Incidentally, if Edit Layers Local Merge was disabled at this point, it would be topping out my VRAM right now and write the access into my regular memory. Simply because loading this amount of terrain all at once without that option is actually quite heavy. With it enabled though, you'll notice that I'm not even reaching 18 gigabytes of my VRAM right now. So it's actually quite a savings. I've noticed it drops about half, 50% more efficient. However, if we were to use landmass, so let me go to landmass and I create a landmass blueprint. Let's just drop one down here, doesn't matter what it is. Then notice how suddenly my VRAM jumps up. And that is because landmass does not benefit from the component-based virtual textures. It still operates on a landscape-based virtual texture. So the larger your landscape is, the more memory it's going to use. In fact, if we actually look at landmass and we were to scroll down, here is the texture that it's rendering that describes the height map change that this particular landmass blueprint is making. And notice how it moves based on its position within the actual landscape itself. So that is something to keep in mind, that landmass doesn't benefit from this optimization, but at least it works. In 5.1 it simply didn't work at all. So in our case, like I said, I'm not going to use landmass, so I'm going to delete that. However, like I mentioned, we are actually not going to use the landscape splines within this project. I've actually created my own blueprint splines, which talk directly to Houdini's terraforming system, and they create a very clean and integrated terraforming for roads, which frankly, at least in my opinion, is much better than what landscape splines can do anyway. Anyway, let's move on and let's actually get started on explaining what the toolkit actually does, right? So if you want to know more about the toolkit, go ahead and visit my website at ehoudiniacademy.com/massiveworlds. But okay, let's actually go ahead and talk about what the Master Worlds Toolkit does. Like, how does it work, right? So basically, the toolkit is a Houdini-based framework for open world construction in the Unreal Engine 5. It provides a framework that synchronizes the Unreal landscape and Houdini tools and allows to share its data. It can extract out the Unreal landscape as layer and tile data in a couple of different ways. Firstly, it can extract the landscape to a single BGO file. So each of these individual landscapes can be extracted to a file its own project folder. And these can be loaded as a whole. They're a large file, but they are simple to load, and it will store all the landscape data that the Houdini engine has been able to extract from the landscape. Next to that, we can also save a small landscape world data file. This one contains the positions and layout of each respective landscape and other important data. Because it's a small file, it's easy to load, and it's used throughout the toolkit to identify where a landscape is and how it is constructed. And finally, the extract landscape asset can also create PNG tiles for the landscape in the same format as the Unreal import and export format. These tiles can be loaded by the toolkit directly, and in this case, all it really does is grab the current state of the terrain and write them to a bunch of tiles. I'll talk more about this in a minute. But these snapshots are more useful for quick editing and quick checkups of the landscape, whereas the BGO is used in the main pipeline of the toolkit. So let's quickly go over how that works. If we go over here, we have a simple setup where we have a process and export node. This is the PNet node, which functions as an importer and exporter of the landscape data between Unreal and Houdini. We feed it a BGO file. We can do some terraforming or material manipulation, and then we feed it to the output PNet node, which can then export out that data back to tiles, which can be imported into Unreal. So here you can see how we take the PNet node, do some editing, like stamping in some roads. We can apply some materials. And then finally, we take the output or export PNet node, and then we can render it out to tiles. So in this instance, I'm rendering out a couple of layers. It runs this in the background using the PDG, and then it will output it as these tiles, which we can then import right back into Unreal. So we go here, we get this. So the landscape can be modified between PNet nodes using the terraforming nodes of the toolkit, such as the weighted height transfer and the blended material transfer. Now these nodes conform to the same behavior as the Unreal Landscape Editor, so you can kind of think of it as procedurally modifying the Unreal landscape in the same way that you could do if you were to manually modify it, using the Unreal Landscape Editor. Now, once you're done, these landscape modifications are written back to the standard landscape format of Unreal. Like I mentioned before, they are the Unreal compatible PNG files. You can then import them directly to the landscape, and this can even be automated, the import process, using a plugin. Plus, the toolkit itself can load these files as well to load the landscape information on demand. And it has the same level of precision that Unreal does. So everything should line up perfectly. Now, other than tiles, the Master Worlds Toolkit also uses a folder structure that contains interoperable cached data for use between Houdini assets, such as road splines, propsing. We have mesh stamps, which we're going to make in this workshop, and also blueprint information, such as the road splines, which we can extract directly from Unreal. And then this data can be loaded on demand as well. So per cache, per landscape, or as a whole set. So in this case, I'm using the load multi-caches node, which is able to load various data sets at the same time for multiple landscapes. It's very useful if you're working across multiple landscapes, and it combines this data seamlessly together as well. So basically, if you're looking at your data in Houdini, it would look like this. But because the toolset uses an externalized data cache, everything is synchronized between Houdini and Unreal, so both data sets will line up, as you can see here. Now, there are various tools available in the toolkit, including a new set of road editing and infrastructure tools. The road editor asset allows you to quickly draw roads using interactive spline editor. It features advanced slope sensitive pathfinding and caching, and allows the user to quickly draw entire road networks that conform to the terrain. In version 1.1, it works better natively inside of Unreal, and it now also comes with a proper post-processing system that will create final smooth roads with proper curvature, flat intersections, switchback turns, and you can configure this per road type as well. Now next, if you were to require more precise in-editor control for your roads, you can also use the Blueprint path splines. These can be interconnected to each other and to the existing road network in a smooth transition way, and they can also be extracted to the Blueprint spline cache for Houdini to see. Now this is very useful because it allows you to create very precise roads with minimal effort in the editor, and the cache system allows other assets in the toolkit to see their positions and curvature as well. Then next, another Blueprint spline asset is the selection blueprint. This asset has options to quickly mark an area, set its curve type, as well as the operating mode, and then push it to Houdini. So, for example, in this instance, I can use it with the vegetation loader to quickly select an area where I want to mask out some of my trees. Use a tag system, so in this case I can delete the trees or the rocks or everything as I need to. The toolkit also now includes a new infrastructure toolset, including the Bridges and Tunnels tool. This asset, as its name implies, creates bridges and tunnels. It can construct them using instances or by deforming meshes that are sourced from the content browser into new regenerated meshes. Also, the tool is highly configurable and it uses data tables and customizable controls. So if you need to modify your tunnels or your bridges, you can do that on an individual segment basis. Next, while key components of the Worlds Toolkit are provided as black boxed assets, I'm also providing several open assets as well. These assets allow you to understand how to use the Worlds Toolkit's nodes to create your own tools for the framework. For instance, this tool here shows how barriers can be instanced next to roads. And for a more complex example, please check out the simple biome spawner asset. The biome spawner uses data tables and various presets to create biomes across the map, as its name implies. It can save these to a cache file and then, when set into loading mode, load them on demand to ensure they are always snapped to the terrain, even if the landscape were to be updated. So basically, you can fill your entire world with trees fairly simple. I'm working on a couple of updates to this system, including a new loading function, so look for more updates to this in the future. And then finally, there's also the background task manager, which uses the PDG. It's used to compute caches in the background. So basically we can set up a couple of nodes here, such as one that terraforms the roads. We're going to add our mesh stamp in here today, and we can also create overlap tiles which allow the landscape to function seamlessly. So in this case, we can just package an entire terraforming network into one of these nodes and then run it as a background operation using the PDG. One of the other benefits of using the PDG is that it can also be run in the background and triggered from Unreal, meaning that we don't even have to go into Houdini to recompute our paths. Once we're happy with our path layout, for example, we can send this task to the PDG and it will spit out a bunch of new tiles for us, always in the same consistent manner. So basically background computation for your procedural data. It's very useful. All right, so let's go ahead and explore some of the tools that are available in the toolkit a bit more thoroughly. Let's have a closer look at the key nodes that you can use to create your own assets. If you haven't done so already, please go ahead and look at your Houdini example scene file, right? All right, so here we are in Houdini. And if you've opened up the example project Houdini scene, you will find on the left a couple of nodes that are showing some of the components that we'll be talking about in today's workshop. Let me just go over and open up the big screen. Now I've added numbers to each of these individual sections, which match up to the slides in this next part of the workshop. So if you want to follow along, you can have a look at each of these individual components, right? And then finally, we have the workshop assets here, which we'll be looking at more closely later. Let's go to the first slide. So the first node that we're going to look at is the load layers node. The load layers node can load values on demand from the layer tiles exported using the pnet node, and it can write these values to the input geometry, or it can output the actual tiles themselves as height fields. And in this example, you can see that if I move about the selection curve here, it can select different parts of the landscape, only the ones that are required. And then this road spline here can be snapped directly to it as well. Next, we also have the multi-caches node. The load multi-caches can load both cache and tile data from multiple landscape projects simultaneously, and then position them correctly using the world data cache file. So no matter where in the world your data is located, it can load it on demand, which is very handy if you need to load, for example, 2 different parts of a road network that cross multiple landscapes, and make sure that they are properly connected together. Now, in order to load our road data, we have the recombine paths node. The recombine paths node combines both the post-processed road data as well as the blueprint splines, and it combines them together and can even load multiple landscape data simultaneously in order to make a proper transition between landscapes. It's basically the core loading utility for all path caches. Then next, we have the blueprint spline input node. Now, when we have a blueprint spline in Unreal, we can provide it to any tool in the Master Worlds Toolkit, and using this input node, we can convert the attribute data that's stored on that blueprint input into actual attributes that are usable by Houdini. This is an open asset, so go ahead and have a look. It allows you to create your own modifications to the blueprint splines as needed, and then convert that data over as well to Houdini, right? Now next, in order to make sure that we can actually work across multiple landscapes, I have the world transform node. This utility gathers and corrects the relative world and landscape offsets of an asset in Unreal to Houdini. So basically, it gathers the world position of the Houdini asset, and it allows it to correct the position of your inputs and outputs so they all line up together. It can handle any common transform or rotation scenarios, so you can ensure your data always lines up with one another. For example, you can make everything in your scene in a centered world center position, even though in Unreal it's at an offset, right? And then translate it back and forth so your tools always line up with one another. Next, we have another utility node, the node preset asset. This is a utility asset that can save and restore the settings of any targeted node. It does this by saving the parameters of the target node to an external file for each asset type. So you can save out different assets, different HDAs, and preserve their settings. This preset can even be loaded automatically when the node cooks inside the PDG. I've got an example of that in various of the nodes of the toolkit, including the biome spawner example asset. So you can have a look there. And it allows the asset to be configured using predefined settings whenever it runs in the PDG. This allows you to create consistent computations, which are very configurable by, for example, a lead artist who configures the settings, and then everyone else, when it runs in the background, just gets those settings automatically applied, right? Nothing's hard-coded, everything is configurable. And this is what this node facilitates. And then finally, before we get started on the workshop, let me quickly cover a couple of useful techniques. First, let's have a look at the pnet node, or the process and export tiles node. This is the primary method of importing, processing, and exporting the landscape tile data between Houdini and Unreal. So if we feed this a landscape extract BGO file and its world data, they can be loaded into a PNet node, and then we can use the terraforming nodes here, for example, to modify the terrain and then export it out again. So these nodes have two key inputs and outputs. One, the blue one, contains the landscape data for the edit layer you are currently manipulating. So if I'm manipulating my procedural edit layer, then that's what comes out of the blue dot here. The green node, on the other hand, contains the world data, which allows the landscape to know where its tiles are and any other important data that you want to carry over. Other nodes in the toolkit, such as the weighted height transfer here, can use this to manipulate the landscape's edit layer. But it still functions in the same way as any other Houdini height field workflow. So as long as you preserve the key attributes and layers on the height fields, you can modify the landscape in any way that you wish and then feed it back to the exporter for export to Unreal. So when this is done, the asset can be told to export these changes to tiles, and then any changes are composited back to edit layers, which are then exported to the native Unreal PNG format. I already covered this to some extent, but I just want to make the fine point about it. When these are exported out, they come up in the tile folder, and that's basically how we get our stamps for Unreal, or our landscape modifications to apply in Unreal. Now, next to the layers that Unreal needs, such as the edit layers and the material layers, we can also output our own custom layers, as well as custom composite layers. Now, custom layers are layers that aren't present in the Unreal landscape, but we can create those if we need to, which can be useful to store various types of information for other Houdini tools to use in the landscape format. Next to that, we can output composite data, which is basically a composite of the various edit layers at different stages, based on whatever our tools need, right? If we want to create roads, we don't want to have height information which already has roads. We want it without, because we haven't actually created them yet, right? But if we need custom sets of data, we can also create our own custom composite layers, which are copies of the existing layers. So we can, in intermediate stages, create sets of data that can be used for other tools. Now, speaking of custom layers, here we have the Add Custom Layer node, and this one can add new layers to the height field that don't exist within the default terrain of Unreal, which we can then manipulate like any other material layer. So in this example, I'm creating a custom layer for the top of this Houdini logo here, and then I can just export it out to a new layer of tiles, just the same way as any other. Here you can see it, it's over here. And then we can load this using a load layers node or a load multi-caches node as required. So think about storing your own layer information as tile data, perhaps not used by the Unreal landscape itself, but it's available to all the other assets that might need it. And then finally, these custom material layers can actually also be loaded by the PNet node if we set it to hybrid loading mode. So instead of just loading that BGO extract file, we can actually load layers from tiles as well. This is a bit of an advanced mode because it's easy to screw things up if you don't know what you're doing, but it basically allows you to load in custom layer data when you first import the landscape for editing. So even custom layer data can be included with your actual pipeline. And then finally, let's talk about landscape snapshots a little bit more in detail. So when we're trying to extract out our data from Unreal using the snapshot function of the landscape extraction tool, we can basically send this to a separate folder called the snapshot folder. This folder creates a quick snapshot of the terrain, and it is only used by tools when it's requested by the user, and only when these layers are actually present. Because of this, it is easy and safe to discard these layers as well when you don't need them anymore, and you don't have to submit these to Perforce. Why would you use it? Well, it's useful for individual artists or users. It bypasses the full terraforming system by basically just capturing the current state of the terrain into a separate snapshot folder. It doesn't require write access to the master tiles on Perforce, and like I said, there's no need to submit these to Perforce, but your tools can see the changes. So it's useful if you quickly want to modify the terrain, capture its recent changes, and then make a tool see the difference. So here's a video where I'm demonstrating this function. So let's play it and I'll talk over it. So here we have the landscape, and if we zoom in here on this ice flow, this little glacier here, we can see that we have some vegetation that's spawned in this area. But if we click on it, you'll notice that there's far less vegetation in the snowy area than there is in the grassy area. And that's because I've told the spawner to cull out parts of the vegetation when it is inside a snowy region. So if I go ahead and modify our terrain here, and I scroll down and find the snow layer, I can go ahead and let's say paint a small area. So let me increase the brush size a bit, its strength. Of course I need to select the correct landscape, and then let's go ahead and paint some extra snow in this zone. Now you'll notice that the vegetation here is probably too much to be inside snow, right? Or maybe we don't want this type of vegetation in a snowy area to begin with. So we could, of course, export out the landscape and then run the entire terraforming process in order to get this captured into our tiles master folder, where all tools will be able to see this change. Or we can just export out the layer data as snapshot tiles using the exporter and then update the loader instead. So I'm going to go over to the landscape exporter tool, and I'm going to re-import the landscape. This normally takes a minute. If you're in Houdini 20 in the current build, it might take actually longer than a minute, but that's beside the point. Let's go ahead and go down here. I'm going to tell it to use the black box HDA. I'm going to reassemble my file path so the PDG knows which HDA to load. First, I need to make sure that it has the landscape data assigned, so we click on this button. Then it basically knows which layers are present inside that landscape. We can then tell it which data we want to output. In this case, we want to only output the weighted material layers, because what I really care about in this case is to render out a snapshot of the snow layer that I just painted, which is a weighted material layer. And then we can go up here to the PDG, and we can tell it to render out the landscape as snapshots. I'm going to reset the PDG for starters, and then I'm going to click on the render function here. It will then in the background compute out some changes. Basically, if we go to the tiles folder, then we go to the landscape 2 folder, we go down to snapshots, we can see here all the material layers that it's currently writing out, including our snow layer. So if we go down here, you'll see that our latest change has now been recorded into the tile cache. This now means that the vegetation can read it as well. So we click on the vegetation, and then if we scroll up, I'm going to reload the tool, click on rebuild, and that should allow the vegetation to see the change. Now, to explain what's happening inside the tool while it's loading, you can actually go into the tool, into the simple spawner, and check it out. In here I am loading the snow layer using a load layers node, and then I am using a culling function here to remove randomly a certain amount of vegetation based on the snow density. Now I'm going to speed this up a bit because purging the previous result can take a second. But you might notice that the trees haven't actually vanished, and that's because by default the tool will not load the snapshot data. It will only load it when you tell it to try loading snapshot data first. This is by default off because normally we don't want to use snapshot data because it's basically just a simple capture of the current terrain and it might get in the way. But in this instance we want to use it, so I'm going to turn it on. And as you can see, now the tool knows that there is now snow in this area because we extracted it out to snapshot tiles and we're loading those tiles so the vegetation gets called out. It's a fairly quick way to grab the current state of the terrain, and this can also be used, for example, for sculpting an entire island in the map, and then we can extract that out and then use that for, say, the vegetation layer. So this island here was written to the macro layer using manual sculpting and then extracted out quickly using the snapshot function. Okay, so let's move on. Next, the toolkit also makes heavy usage of data tables. So data tables from Unreal can be loaded into Houdini. For Houdini, that means that they can be exported as CSV files, which are in the data tables folder on the Massive Worlds project folder. Or they can be loaded directly in using the Houdini engine. So in this case, I actually have a system included inside the vegetation spawner that can load either the data table directly from Unreal or from a CSV file. It's fairly straightforward once you figure out how it works, but it allows you to control your assets using an external data set. It's very easy to create presets this way and control your assets. And then finally, let me show you this technique. It's a dynamic asset input. So normally when you are using an asset and you plug in, say, a static mesh from the content browser, you have to do so manually, right? Which means that if you want to load a mesh into a tool, you can do that, but it doesn't automatically apply it based on what the tool requires. So the dynamic asset input example allows you to use data tables to grab any number of assets from the content browser that the data table requests, like here, for example. And then it can use those to create a new bespoke mesh, such as the road deck for the bridge here, which needs to be smooth because if the bridge is curved, instances don't always create proper, clean trajectories for cars. This allows you to take meshes, sweep them along a curve, subdivide them, and basically create a clean road mesh, a new mesh from components that were loaded from the content browser. It's fairly useful, so have a look at this if you're interested. Now let's have a quick look at the barrier and spawner asset, which are the example assets that are part of the toolkit. I won't take too long because I don't want to lose too much time. But if we pop over back to Houdini and we find the spawner asset, which is located here, and the barrier asset, which is located here, let's have a look at this one. The barrier asset first. So the barrier asset is a very simple asset that can be expanded on further if you want to. Basically, it loads the road data inside your scene. Let me just hide that. There we go. And this road data comprises the roads and their various positions across the world. We can then use a load multi-caches node to also load the landscape data inside that area as well. In this case, I am loading the post-procedural composite layer, the final layer containing all height layer data. And then we can process those together. Firstly, we can identify where sharp corners are in the terrain. Then we can filter out those sharp corners and create only barriers on the outsides of the terrain wherever there is a sharp cliff. So let me just show the terrain at the same time. And then finally, we can assign a bunch of meshes here. So we snap it to the terrain and then we can assign some meshes in this area. Now these are then instantiated to Unreal, and that basically results in our barriers in the Unreal scene. We look over here in the Unreal scene, and we find a sharp cliff somewhere. Let's say over here. You'll see that if the road makes a turn and there's a cliff on the side, it will place a barrier right on the edge. And this barrier should be lined up with the terrain properly. Like, it should be on the right height and the right angles as well. You can do this also for road markings as well, for example, or placing traffic signs, various other options. You know, you could do that with a system like this. Next, let's have a quick look at the vegetation spawner. Now, this tool might take a moment to load because it's currently spawning several layers of vegetation across the entire map. This might take a moment. So one thing you can actually do for the spawner is to limit the area that it's spawning in. So I'm going to exit out of this. Then we can go to, instead of spawning for the full map, we are only going to spawn by tile ID. Go to refresh the tool. And then we'll let it load in that landscape data and spawn a bunch of trees, bushes, and rocks in this particular area of the map. I'll give it a second to load that. So as you can see right now, it's doing its spawning passes. 8 out of 14. Should be done in just a second. All right. So here we go. We've spawned some vegetation across the map based on a bunch of spawning rules which are defined down below here. Now these spawning rules can be set up one at a time. You can control which vegetation you're trying to spawn, where it should spawn, for example, what biome it should spawn in, what curvature of the terrain it's allowed to use. You can introduce noise, set minimum and maximum altitudes, as well as the slope. And then you can also tell it, for example, to filter out spawning in the proximity of other objects, such as, for example, a tree could avoid spawning close to another type of tree, right? Now the idea is that setting this up takes a moment of time, but you can then go and create a preset. If I go to the preset function of the node, and then if we look here under the preset tab, we can actually save this out as a preset. So I could say I want to save this out as preset tree. Arm the exporter and then save that as a preset. And what that will do is it will save the settings of this node, all the settings of this node that we're telling it to save, to an external file, which can then also be loaded using this function. It can actually be loaded automatically when the node cooks, though there are a couple of caveats to that, mainly in terms of how memory is managed, but I won't be going too deep into that here. Now, once you've created your preset, you can then compute this in the PDG for the whole map, because you might have noticed that spawning some of this vegetation did take some time, right? And this is only on a small portion of the larger map. So if we want to do this for the full map, this might take a minute or two. Now, once you've spawned the full map though, you can then say, I want to save it out to a cache on the hard drive. Arm the exporter and save the cache. Then we can tell it to load that cache using the loader. So in this mode, we are simply loading an existing cache. I can load the full cache as well if I want to. Give that a moment. Now do remember that at the moment the tool is still set to only load a certain part of the map. So I'm going to set it back to full map. And that means that now the entire data set, which is present here on my hard drive, is going to be loaded. If we do this in Unreal, it's going to be quite a lot of vegetation. I would actually recommend you create multiple loaders. I'm currently working on this process, but the idea is that it will load the vegetation and then automatically call out the roads and the vegetation in the proximity of roads. So that, for example, in Unreal, if we look at a road that goes through a forest, the vegetation that's present here is automatically going to be removed, right? So if we find a place where we have a lot of dense vegetation, the vegetation spawner, or rather the loader, is going to make sure the trees are at terrain level and that they stay away from the roads at least a certain distance from the roads. So we don't have to worry about any vegetation overlapping the roads, right? The same thing's true for any exclusion curves that we might have added. So as I've shown in one of the previous slides, maybe we don't want vegetation on the Houdini logo here. We show this. We have a blueprint spline here. This one's plugged into the loader, or like in this case, for example. And then we also have the ability to see which props are being deleted. So in this case, this curve here deletes these particular tags. And then if any of the tags on a prop match, it will remove that prop. So that's why the trees in this area are removed. If we look inside the tool, this is quite a lot more complex than the barrier spawner from just now. But basically here we're loading all of our various data sets. In this case, any curve inputs that we have. We can load our terrain based on the area that we currently need to load. Of course, depending on how many layers you're trying to load, how much data you're trying to load, it's going to take a bit longer to grab that data. But it is still fairly fast, so give it a second to process an entire map's worth of tiles. There we go. There we go. This is landscape 1, as well as various of its layers that we're currently using. And then we can load the selection splines. Over here we're loading our data table information for the various props in the map. Different types of trees, plants, rocks, etc. This information comes from the data tables. Here we're grabbing the blueprint splines if they're plugged into the tool. And this one grabs the road information. So all of this is basically lined up together. Because if we grab this and we just, let's say, combine it all together, you're going to see that we have everything aligned in the same place thanks to our world transform nodes over here. Alright, so then this is basically processed in a spawning loop where it places each layer of vegetation one at a time, and then finally we have our outputs and our visual outputs and the export function. And then here on the left we have the import function, so we can import that cache that we saved out to disk, then do a bit of post-processing, do some culling, and then finally, again, we output it to Unreal. Now in this case you'll notice that this landscape is offset, or rather the objects are offset, and that's because the tool itself actually has a position in Unreal that doesn't match our centered landscape position. This is because of the world transform. If we go over here, before the world transform, you'll see that all the props that have been spawned do actually line up with the terrain. This is how we translate between Houdini's centralized space and Unreal's offset world space, right? Because this landscape is not at the center of the world. The center of the world is about here. So that translation is handled by the world transform node. Okay, if you want to have a look, go ahead and investigate into these assets at your own time. But let's move on to the actual workshop portion.